All right, we'll get started. So just to double check, we just put this slide up. We ran a part 1 and part 2 session on Tuesday. A good 60-70% of the content is going to be the same from those 2 sessions. So if you went to those 2 sessions, then please, there's not much, there will be about a 30% extra in this session. So before you all do your evals and say it was exactly the same, we're warning you up front. It is very, very close to a consolidation of those 2 sessions. So just giving you fair warning right now. So welcome. This is deploying and managing applications on Windows Azure. My name is Adam Hall. I sit inside the Windows Server and System Center Management team. I have responsibility for the scenarios and the capabilities around the application platform on Windows Server, the application management scenarios on System Center, and in this case, the managing of applications running on Windows Azure. With me is Mr. Craig Kitterman, my peer over in Windows Azure.
Great.
So we're going to start off with a few slides and then spend the remaining 60-odd minutes in demo. We want to show you how this comes together. We're going to go all the way from connecting to Windows Azure. Craig's going to show you what a Windows Azure application actually looks like, how we do a lot of that stuff at the back end. We're going to connect to that subscription using App Controller. We're going to monitor it with Operations Manager, show how we do all the dashboarding and performance monitoring around Windows Azure as well. So if that's what everyone expected to see, we're good. If there's something you want to see, we do have some spare time in this session, so please ask your questions. We can go off the estate a little bit. Sound good? Everyone nodding? All right, Craig.
Thanks, Adam. So Adam mentioned we're just going to do a little bit of level set context with slides up front. We don't want to kill you with slides, and we're going to move into pretty heavy demos here. So before we do that, I just want to set very quick context, 2 slides on Windows Azure. This is the purpose of this session is not to explain to you what Windows Azure is, but I just want to make sure that we're all sort of speaking the same language. So when we look at Windows Azure and the type of service that we offer in Windows Azure today is a platform as a service offering. So when you look at sort of the continuum of types of cloud services that are out there, you have your infrastructure as a service, which is probably most notably in market through the Amazon offering, AWS. You get a virtual machine, you go spin up a virtual machine from an image, you manage that virtual machine, you configure it the way you want it, and you sort of own everything from the OS on up. You have to patch that thing with the software updates, security, all of that stuff is up to you. The platform as a service model, which is what Windows Azure is based on, is all about the application. So all of the details of the operating system are sort of abstracted away, and what you're given is effectively a container to go and run that application. And basically, that gives you a lot of interesting flexibility, but it also takes away some of the control you have. So there's a little bit of trade-off there. And then, of course, software as a service is sort of finished service. It's usually multi-tenanted and is delivered directly to a customer. And we're going to talk about platform as a service. So the Windows Azure platform sort of has 3 core capabilities: compute, storage, and we also have a database service. Compute is, as I mentioned before, it's really just that application container. So you'll take an application, bundle it up, and I'll show you how this actually works in just a moment, and publish that application into Windows Azure. Windows Azure just runs that code. You can then specify endpoints. So for example, if it's an internet application, a web application, you specify, hey, this needs an internet endpoint, an HTTP endpoint, so people can actually use the application, and you just configure all that in Windows Azure. We have a very robust geo-distributed, fully redundant storage system as part of Windows Azure. And if you're familiar with Amazon S3, this is very analogous to Amazon S3. We have a number of different services that are part of the storage offering. We have a blob storage service, which is basically any arbitrary binary data can be stored in blob storage. Think of it as effectively a file system in the sky. We have a simple key value store. We have a simple queuing service. And all of these are part of the Windows Azure storage capability. And last but not least, we have a relational database, SQL Azure, which is a basically multi-tenanted but highly scalable, redundant, highly available database that's very easy to provision and doesn't require any management. And it gives you a logical database that you can connect to using existing SQL Server type tools because it speaks the same TDS protocol as SQL Server. So it's a very easy way to get a database up and running in the cloud. Okay, that's all I'm going to tell you about Windows Azure for now. And I'm actually going to show you just a couple of things. Because what Adam's going to show you in a few minutes is inside of System Center how we actually manage and monitor the application once it's deployed into Windows Azure. I want to give you just a little bit of a peek at the developer view and what developers need to do in order to appropriately instrument the application so that when you go and you set up the management and monitoring pieces, that application is ready for all the right performance counters and dashboards that you want to build. So I'm in Visual Studio here. I know most of you aren't developers probably in the room, but I'm just going to show you very quickly how little code it takes to actually set up and instrument the application, and it's really easy for developers to do. So I'm in a Windows Azure application here, and this is just a worker role, which is one of the types of compute that Windows Azure offers. It's simply just a run loop that goes and does some work and then sleeps and then goes and does some work. So you'll see here there's just a very simple run loop. And there's a startup method that gets called when the compute node actually gets instantiated. And inside of that on-start role, I just needed to add about 10 lines of code to turn on performance counters and the like. I also only needed to add one extra piece of configuration information into my config. Now my application's ready to go and ready to be published into Windows Azure. So I'll show you what happens when you have a Windows Azure application in Visual Studio and you say package, what you actually are going to get. So when you package an application that is a Windows Azure application, basically the result is two files. The first one is a CS package file, and this is all of the code from that application just bundled up into one sort of glorified zip file. And the second file that you get is a configuration file. And this specifies all the characteristics of your application, tells Windows Azure how to handle your application, how many instances of that application that you want. And this is really important from an IT point of view to really understand what's in that config file and make the necessary adjustments to deploy the application appropriately. So when your developer comes to you and says, okay, here's my app, these are the two files that they're going to hand to you that you need to go deploy and manage. And there's a few different ways to deploy an app. Adam's going to show you how we do that through App Controller. I'm going to show you very quickly the Windows Azure portal and how you actually can deploy an application through the Windows Azure portal. So the Windows Azure portal is just a simple web-based, Silverlight-based application. And if you want to deploy a new application, all you do is create a new hosted service. You can think of hosted service as an application. It's basically a container for an application. I'm going to go ahead and just give this a name. And it assumes that I'm going to deploy something that is going to want an internet endpoint at some point. And so it's going to actually give me the opportunity to specify a DNS name that I want to use. This DNS name has to be unique. All Windows Azure applications have the suffix .cloudapp.net, so you can give it any name. And then, of course, you can alias that DNS name with a CNAME record to use your own domain, et cetera. So I just give it a name. I select what region I want to run my application in. So Windows Azure has 6 global data centers in basically 3 different regions, Asia, Europe, and the United States. And so I have the ability to deploy that application in one or more of those data centers to locate it most appropriately given where my users are located. So I'm just going to go ahead and select Anywhere US. And I'm going to deploy to production. So you have the ability in Windows Azure to deploy either to a staging environment or to a production environment. And then once you deploy something to production and something to staging, you can very easily swap between those two things. So you can move things in and out of production with a click of a button. So I'm going to give it a name. And then all I do is simply upload those 2 files that my developer handed me. And go ahead and click OK, and then we're all set, and our application is going to be deployed. This warning here is because in my config file, I only specified one instance of my application. And to get a full SLA from Windows Azure, a 99.95 SLA, you have to have at least 2 instances of your application running. And that's so that when you do updates and when the Windows Azure system actually updates that underlying operating system, it can do so in a rolling fashion and not take your entire application offline. And so in order to maintain that SLA, you have to have more than one instance of the app. But in this case, I don't care, so I'm just going to say OK. and then my application will start spinning up down here. So the other thing that we've done is we've gone ahead and built an entire suite of PowerShell commandlets to interact with Windows Azure. So all of the Windows Azure service management APIs that allow you to deploy applications, manage those applications, scale those applications, those are all available now through PowerShell commandlets. So let me show you an example of that. I've got an application running here. This one's called MMS Perf Test. This is, I think, the app that we're going to show in a few minutes here in System Center. And I've got a very simple PowerShell script here. Basically, this script has two components to it. First, I just have to set up the certificate. So when you want to do something in the Service Management API in Windows Azure, there's a certificate exchange process that needs to take place beforehand so you have trust between the client and the server. So in the Windows Azure Management Portal, I have a folder here called Management Certificates. And all you need to do is simply create a certificate and upload it with the public key, and then install the certificate and the private key on your local machine. You set up in PowerShell, you simply assign a variable to point to that certificate. I set up my subscription ID, which again I get from the Windows Azure portal. If I click on my root node here, which is my subscription, I get this sort of GUID-looking subscription ID. I paste that into my script here. And then I simply call a PowerShell commandlet called getDeployment, and then I pipe the result of that to another PowerShell commandlet, setRole-InstanceCount, and that's going to actually increment the number of instances or decrement, depending upon what I want. So in this case, I currently have one instance of my application running. I'm going to go ahead and crank that up to 10. And within just a few moments, Windows Azure will spin up 10 instances of my application. It's going to create 10 new virtual machines. It's going to image those virtual machines with my app code. And it's going to set those up behind the load balancer all automatically for me. So if I go back over here to the Windows Azure portal and find that application, the status of this should change momentarily, and we should start seeing those 10 instances spin up. But that might take a few minutes, Adam. So,
There you go.
Oh, there it goes. OK. So now you can see those have been provisioned, and they're waiting to start.
So what we're going to do now is to say, so you've got your Windows Azure subscription up, you've got your application deployed. What does that look like when you want to take control from on-premises, and how will you do that with System Center 2012? So we have two components of System Center that work with Windows Azure today. The first one is App Controller, and App Controller is about connecting to that subscription, viewing the hosted services that are running, and the ability to interact, scale out, and do some things manually. And then we have Operations Manager, which is about connecting to that hosted service and seeing the performance and availability of the application and being able to do things like dynamic scale based on load. So we're going to show you two parts to App Controller. The first one is I'm logged in as administrator here, and administrator is an administrative account is where we manage which Azure subscriptions we connect to. So I have one small, anyone who's done the private cloud immersion would have seen the PCI Azure account that we use for that. I'm going to go ahead and add in the subscription that Craig was using. He has provided me with all of that information. So you need 3 pieces of information to connect to Windows Azure from either Operations Manager or App Controller. The first one is we need to pipe in the subscription ID. We'll call this MMS demo. I need the management certificate. So Craig used. He set up the public key in Windows Azure. I've got a copy of the private key here. So all of the key exchange is encrypted. Just checking the password. Highly secure, this one. All right. And with that, we've now connected to that subscription of Craig's. If we come up to services, we're going to get a large amount of services turn up. And we will see the one that Craig has cranked out to 10. We can see the transition. So App Controller gives us the visibility. The dark blue ones that you see here are connecting to Virtual Machine Manager in an on-premises private cloud context. And the light blue ones are Windows Azure hosted services. So Craig spun out 10 additional instances. We see that same structure, and we can get a diagrammatic view of what's going on there as well. So this is a simple one-tier application, and there are all those instances spinning out. So we get to see what's going on in real time through App Controller and being able to connect to that. Now, One of the things that App Controller allows you to do, and it's pretty much the only thing that App Controller does that no other part of System Center does, is it allows you to delegate out the Windows Azure subscriptions to internal Active Directory users and groups. And we do this through user roles. So we have a number of user roles here, and when you create a user role, you specify a few things. One, this user role can be read-only or read-write. If it's read-only, I can simply see what's going on in Windows Azure, but I can't change anything. I can't deploy new services. I can't scale an application. It's simply a view-only option. If that's not ticked, then it means that I can interact with the environment. We've got a couple of Active Directory accounts that we've given access to. It can be Active Directory groups or users. And then we specify which of those subscriptions that user group can see. So we already had access to PCI Azure. We'll add MMS demo to that group and go ahead and set OK to that. Now we're going to jump over and bring up the App Controller version. If I close that one, I'm done with that. Now I'm going to bring up I'm logged in as a self-service user. I'm no longer an administrator. I don't see the settings down the left-hand side. I've got a couple of virtual machine manager clouds, but only one Windows Azure subscription. As I do a refresh, that comes to 2. I've now been added into that additional group. And if I go to the clouds view, I can see the subscription that Craig gave me access to. And again, I can now see those same hosted services that are coming through, and it's transitioning out. When it comes to, Craig showed you through the Windows Azure portal how you can browse to those files, the configuration files, the package files. That's how you do it from Visual Studio. That's how you do it when developers and people bypass you. All right, what we want to encourage is to get in the middle of that conversation and say, if application owners, people who own the applications in the environment and developers are using Azure, to come see you and do it in a controlled way. It allows you to control what's going on. You can take control of things like billing, take control of how much capacity has been used in Windows Azure at the subscription layer, but it also allows me to take an offload from the developer to a file share. I have a standard file share set up here. We have the configuration and package file just sitting on a standard file share. I can copy those files, go across to the Azure subscription, and I can drill in and see all the same information in App Controller that you could see in the Windows Azure Silverlight console. I can come down. I can create if I wanted to create a storage account, I could do that. I'll just go into the MMS option here, and I can create all the containers. So all the things that you would do to store this information in Azure, you can do in a self-service way through App Controller. We can create a container, or we can simply, actually we'll create one. Just put them under my name. Now it says create container down the bottom there. Craig showed you the PowerShell provider. Everything that App Controller is doing is going through the Windows Azure Service API, and it's using PowerShell commandlets, and it's talking directly to the API. This is an open API. Everyone can connect to it. We've just simply coded App Controller to use that API. It's available. If you have your own mechanism for connecting, you can connect to it as well. So now I can paste those files up, and where Craig went to a portal and had full administrative access, he could do everything with Azure in a self-service way. I can do the same thing, but I have no idea what the live ID is. I have no idea about the Azure subscription itself. All I got was a big long string of numbers, a certificate file, and a password. Okay? I'm doing it in the same way, but I'm doing it in a controlled fashion. So now that we have uploaded our package and configuration, we can come across, select our cloud, and choose to deploy a new application. When I do that, it's going to validate that this is the cloud that I want to connect to. We can configure the hosted service. Can I choose one of those? MMS demo. Yeah. That's fine. So you can create that new hosted service with the URL and all those details. I'll configure one that Craig's already got there. From a deployment point of view, we better give it a name. So I'll call it Adams MMS. Help if I could type. Get to choose the operating system. Now, here we have, these are all of the operating system images that exist up in Windows Azure. You can see it's got the standard Windows Server 2008, SP2 and R2, as well as all the Windows Azure guests. And this is where all of that patching's been done for you at the platform layer. So if there's a specific release of the operating system that you want to use, a patch comes out, maybe it breaks your app, you can go down to a previous release. I'm just simply going to use Windows Server 2008 R2, put it into staging, it's fine. And now I've got the hosted service configured. What is the app I want to deploy? We're going to browse to those files that I just uploaded as that refreshes. There's my configuration file, which is going to define what is going to be deployed. This is a simple, just a one-tier worker role application. It's going to ask me for the subsequent package file that goes with that. And I hit deploy. That's now going to start a new deployment. If I go across to the services tab, it'll take a sec just to kick that off. As it refreshes, we'll see a new Azure application or hosted service is being deployed. So that's how easy it is to connect App Controller, grab those files, upload them, configure for deployment, and make that available. That's refreshing at the moment. That's going to come through. So any questions on any of that? All make sense? Nice and easy to use. Question? What was the question, sorry? Yes? What's the name of the...
I think it's called Windows Azure PowerShell Commandlets. Yep. Windows Azure PowerShell Commandlets, it's wappowershell.codeplex.com. And if you just search for Windows Azure PowerShell Commandlets, should come right up. It's a Codeplex download.
So you can download it and pull those in. So App Controller is using a combination of the PowerShell commandlets and some direct code that's hitting the API. But the commandlets will cover a large volume. We do some special coding in App Controller to make things a lot easier, but all of the commandlets are going to do a large portion of that without needing any kind of code. Okay. So that deployment has completed. There's my Atom MMS. It was a simple one tier. The deployment is kicking off, and you'll see that that worker role is now spinning up. That'll take 5 to 8 minutes, give or take, on the fabric to deploy out, and then we can manage that application. So one thing, something that we were just talking about there, if I take a look at this diagram view, this is common across the Virtual Machine Manager Private Cloud and the Windows Azure Public Cloud applications. It allows you to see both sides. They are different constructs, but we diagrammatically present them in the same way. So from an app owner point of view, it's a consistent way of looking at it. The formats are different. The application on Windows Azure is different to an application on premises. Okay, the package format is different. The template is different as well. But we go to great lengths to make it appear to an app owner to look the same. But I just want to clarify that they are actually different versions of the application. So now we've deployed our application out, and we've got it up there. We really want to see how well it's running. We want to be able to connect it to our operations manager and see what that looks like. So I'm going to jump over to Operations Manager now. And Operations Manager has, or there is available for Operations Manager, a Windows Azure Management Pack. It's freely downloadable. It's on download.microsoft.com. It's part of the System Center Marketplace as well. And once you install the Windows Azure Management Pack, then it gives you the ability to type in that same information and connect to hosted services and start to get the information back. Now, there is an additional step in the configuration of the application. You have to turn diagnostics on in Windows Azure. Once you turn diagnostics on, it will start writing out all that performance information to a table, and we actually read that table as a way of getting the diagnostic information out. It is one additional step there. So the Windows Azure Management Pack is there. I've already deployed it just to speed things up a little bit. And now we are able to go and connect to our Windows Azure hosted service that we have deployed. So we are going to connect to a hosted service that we have running. It's a simple matter of saying I want to connect to a Windows Azure application, and it's going to ask for a name. we're asked for which management pack do we want to store this configuration in. So if you know Operations Manager, I'm about to teach you something you already know. If you don't know Operations Manager, a management pack is simply a container to store stuff in. Like the zip file that holds the package, a management pack is a construct just to store information, store configurations, store counters, store commands. It's just a big container to store stuff in. So we will use the MMS perf app, that's fine. Now, it's going to ask, what is that DNS prefix? What is the application that we deploy that we want to connect to? So we are going to just use, not that one, the application that we deployed. Now, just for this demo, we're having some DNS issues on the show LAN that we have here at the event. You would typically use the DNS name. We've got some DNS issues going on in the show LAN today, so we're going to use the IP address to connect instead. Just simply from a demo perspective, we have some challenges there. So once that is in, we can connect to that. Actually, I think I need, my apologies, that. Subscription ID. So we know what the hosted service is. Anyone in the world can go and find that. Just do a DNS lookup and you'll find it. But now we need that subscription ID again. So just for security, we grab the subscription ID, paste that in. Now we're asked which environment are we going to monitor. Craig talked about staging and production and the way that you can deploy to staging and flip it up to production and switch those over. We'll connect to both. It's going to ask us for the certificate and the password. So in App Controller, we simply browse to the certificate and typed in the password. Operations Manager has a construct of run as accounts. And so we've created a run as account where we've loaded up the certificate, and we've also created a run as account which has the associated password. Those are just two things that your Operations Manager administrator can do for you. It is a 2-second job. Once you pass it in, then you are good to go. Okay. We have to fool it and then go and fix it.
I think it just wants the first part.
Is that what it wants?
I think it just wants the MMS perf because you got your
we've already got
.NET there.
Try that. There we go. Now it's going to say, how are we going to connect to Windows Azure? And this is really important from a monitoring perspective. A lot of internal management servers won't have internet access, or if they do, it's highly restricted. And so what Operations Manager allows you to do is to proxy the connection to the internet through a specific agent. And so you can browse here, and any server or workstation that you have in your environment that has the Operations Manager agent deployed to it can now go and do these proxying requests on Operations Manager's behalf. So we're just going to go out from our Ops Manager server because it does have internet access in our demo environment, but this allows you to go out through a single channel that you can monitor and manage or get around the fact that your servers don't have internet access by default. Click Next, and basically we're done. So in that simple wizard, we've connected to the hosted service, subscription ID, certificate, password, and what the hosted service name is. Operations Manager can now go talk to that, connect to that table storage, and start bringing down all of those perf counters. Now we've got one that takes a little bit of time, around about 15 to 20 minutes it takes to go up to Windows Azure, start polling that information, pull it down into the Operations Manager database, move it across to the data warehouse, and start doing all the number crunching so that you can build dashboards out. In the real world, 15-minute wait's not going to kill you. In a 60-minute session, it absolutely is. So we've created one earlier that is already set up to go. And what we're going to get, as we just wait for the busy signal to break down, is as soon as we do that, we can start to see the information coming back. So I'll just wait for that to do a refresh. It's talking to the database. It's storing all that information. Everything inside the management pack's now being cataloged by the Operations Manager database. All those parameters, all the connection strings have been tested and put together. It's just going to take a sec to come back. Here we go. Now that you've made the connection, now we can start to see information coming back. So if I just move over to the monitoring tab and wait for that to refresh, if we come down to distributed applications, this is going to show us three things, one of three things. It's going to show any distributed application diagrams that we have manually created. I'm going to show you what that looks like. It will have all services deployed with Virtual Machine Manager. There's a connector between VMM and Ops Manager, and as you deploy a service on Virtual Machine Manager, it will synchronize across to Ops Manager and also populate the Service Manager CMDB as well. So as soon as you deploy a service, all the service template information, the virtual machine, the applications, and everything associated with that will dynamically turn up in Ops Manager and will also populate Service Manager as well. We also will get, and you can see here, there's that application that we configured. It's going away and getting that information. In order to speed things up, we've got a couple that are created here already. We can see that it's a Windows Azure deployment. Now we can open up the diagram view, and we'll be able to see that same diagrammatic view as we could see in App Controller, but this time we're going to see performance and availability information that goes with that. And so I've got a couple of very basic applications running here just with a few instances, and you can drill down and see within that hosted service what are the roles that are running and how are they performing. And for those of you that know Operations Manager, all of this is a roll-up view. If one role was getting hammered and wasn't performing well or wasn't meeting SLA, you'd start to see some red dashboard information coming through here. So all of that is coming back from Windows Azure, and we can see how that is performing. You can create your own versions, and we did this morning in the hybrid application demo. What we have done is created a diagrammatic view, which these are fully authorable, and you can bring them in and pull together parts of on-premise and Windows Azure as well. So if you have an application or a service that spans across a little bit up in Azure and a little bit on-premise, some virtual machines, some other stuff, so long as it is populated in the Operations Manager database, you can pull it all down. And so we've got, these are the virtual machines that are sitting underneath our applications that are running on premises. We are connecting to a Windows Azure hosted service, excuse me, and we can see the information that we have there. And we are running synthetic transactions against our application to get that performance information back and to simulate the load that we have running. So now we're starting to get not only the monitoring of availability and performance, but also, well, what's the experience for the end user look like? So those synthetic transactions are created and configured in Operations Manager. As we come across to the web application transaction monitors, these are, and if we take a look at the two that we have here, these are simple transactions that we've set up to poll that application and see how well it's running. So this is the one that we're using for availability. Availability simply means, is it up, is it down, is it available, and how is it, not even really how it's running. So we've got a simple web request that we're hitting that application and looking to see how long did that take to come back. If we run that test, all going well, we should see that it hits that application. We can see that it was okay. We can see the information coming back, and we can see how long it took to do that. Now, inside that application, we can also do things like pulling back the performance counters as well. So if you want to see the content size, the resolution time, the time to first byte, the time to last byte, total response time, all of that information will come back down as part of that transaction. So that's for the availability side. But what about the performance? So the other thing we've done is created a second one which says, well, not only do we want to see just is the app up and running, but let's run something through it. Now, Craig's had fun as a developer and written some bad code. I know it never happens, but we've configured the same application that we've got to not only perform well, but to have some code inside of it that allows us to simulate a bad piece of code. And it has a slow query there, and we can pipe in how long we want to simulate the app being slow. So we've simulated this one to take at least 10 seconds of delay. And this is just purely simulating someone's written some code that goes into a loop state or does something bad, goes looking for something that doesn't exist, whatever the case may be, just simulating that that's not so good. And you can see that this one is taking a full 10 seconds, which we've configured it to be 10 seconds, so it's about how long we would expect it to take. So now we've got not only the availability of the Azure application, we do this for on-premises as well, but we start to see, well, what does it look like when people use our apps? In the configuration, sorry, I meant to show you that before you do this, when you create these website transactions, you don't have to type them all in. You can actually do a recording. And so you can do what's called a start capture. This will launch Internet Explorer and allow you to go click on all the buttons that you want to do. It'll capture everything that you do. And when you come back, it'll list down in this list everything that you did. So if you clicked on a few buttons and walked through the application, pretending to run a dummy app, dummy transaction, whatever it is that you do to test that the app's okay, it will capture all that information, save it in here for you, and then you can just edit it if you want to update it. Or you can just simply insert a request, and we could type that in. So if we wanted to run another one, actually if I take a look, if I do a little bit of a cheat test here, if I take a copy of that one and say, well, not only do we want to check that one out, but let's imagine we had another one. Let's add another 5 seconds to that. We'll save that in. Just take a sec just to update the management pack, put that all into the database, and then we'll come back to us. Now when we do this transaction, it's going to run each of those transactions in the sequence that you see listed and give me the sum total of all of that. Now this is a very simple dummy application. If we run that test, it's a very simple transaction there, but you can imagine in a complex application that you'd be going to multiple sites, multiple pages. Possibly you're not only going to that website, but maybe you're going to a back tier. Maybe you're running a script against some other kind of environment. You can run whatever scripts that you want within Operations Manager and get that information back. I've seen people do everything from just purely running a ping test and then passing the ping test result back as part of this as well, and being able to pull all of that information back. Now that's just saving stuff. Let's close that down. All right, whilst that is working out and saving that back, I'll pull up the dashboard. So once we have that piece of information, and I will go back and show you how I built this as well. I think my system has just suddenly ground to a halt. Must be something going on my server. Apologies for the delay. We're running the web application test. That's a good start. This should take just over a tad over 15 seconds now. We've got the 10-second delay and the 5-second delay. Adding that in. Running. The joys of demoing on a live production environment. There we go. And so now, it actually took 20 seconds, so there must have been some additional lag in there as well. But we've now just run those 2 transactions through. Okay, we've proved our point there. So now that you've done that, the next thing you probably want to do when you're monitoring applications, regardless of where they're running in both Windows Azure and in the production cloud as well, is to set your service levels. And your service levels simply are, how responsive is the app supposed to be, how long will it take to do this, and what is the expected performance. So if we take a look at one that was set up earlier, we give it a name, we specify what is the information that's going to measure whether we met our SLA or not. And in this case, we are looking at the watches group. Now those synthetic transactions that we set up, that is called a watcher group in Operations Manager internal terms. So basically what we're saying is, we want to look at all of the watches that are named MMS perf app. Then we set the service level objectives that we want to apply. And so we've got 2 that we've set here. The first one is that transaction that we are running, we want it on average to take less than 7 seconds. Now we've set a delay of 10 seconds and 5, so it's going to be well over that, but you can set whatever you want here. The whole idea is that you're running those synthetic transactions through your application. You can measure that. You can do it on a good day. You can do it on a bad day. Work out what it should be, a range. You can do less than, more than, however you want, minimum, maximum. We're just doing an average of 7 seconds. That gives us the performance of the application. Then we also want an availability service level, which says, well, when we're doing that basic, are you alive? We expect to get a positive response 99% of the time, so 2 nines of availability. So we're going to be able to measure 2 things, the availability of the app and then the performance of the app under the hood as well. That's all there is to it. You save that. What you then can build is a dashboard. So we're building up and up and up through that. We've configured our app, we've deployed our app, we've connected to our app, we're now monitoring, is it up? We're now starting to take a look at the performance information coming back. We've put some transactions through the application, we've set some service levels, and now it's like, well, cool, how do we know whether we're making that or not? Let's go down to our MMS perf app folder, and we're going to create a new dashboard, and that's as hard as clicking right-click, new dashboard. Operations Manager has a number of dashboards available to you. There's the column layout and the grid layout, which will give you, depending on which one you choose, some sort of layout where you can drag and drop widgets and configure them. You can do a summary dashboard, which is a top N, if you will, which is say, give me the top 5, give me the top 10 issues. And we're going to do what's called a service level dashboard, which from an application point of view is the most interesting and useful one, simply because as an application owner, that's what I actually care about. It's going to say which SLAs do you want to pick from. Now, if we do an ad, we can see all of those service level objectives that we set. We can do both the on-premise. We could also pick our Windows Azure. We could also take one for our off-premise as well, just to make things interesting. It asks you, how do you want to measure that service level? Over what time frame? You expect 5 nines of availability over 1 day, 7 days, a month, a year, whatever you want. So you can wind that all the way down from, hey, the last 5 minutes I need to be highly available, down to forever I want to be, highly available. So we'll in the interest of time, we'll just use 24 hours. The app's been up for a few days, and we hit create. Now, simple as that, Operations Manager is going to create that dashboard. It's going to go and talk to the data warehouse, all that information that we've been getting from talking to Windows Azure, being able to see the construct. Let's browse to a different one. Let's go back to IE. It's now going to populate that data. Now, all that data comes down into the Operations Manager database. It goes across to the data warehouse, number crunches it, works out all those averages, works out all that information, and then presents it to me in a very graphical way. This will just take a few seconds, a couple of minutes to pull back all that information. It's coming out of the data warehouse. It's working out where is that information coming from. It's going to calculate it all and then present it to me on the screen. Just take a couple of seconds. If it takes too long, I'll jump over to the one I created earlier.
Maybe it'd be a good time.
Oh, there it is. There it is.
I was just going to say maybe it's a good time to pause and just see if there's any questions.
Yeah, so you can see on the screen, there is the on-premise expense manager where we've got transactions running through it, and there is the Windows Azure one where we're checking that it's available, and yes, we're up, but when we look at how those synthetic transactions have been running, you can see on average at 13.395. So we set a delay of 10, so basically the app's taking 3 plus the 10, okay? Any questions on all that? I know it was a lot of information in a really short space of time, but the whole point here is that we get visibility into those Windows Azure applications. The management pack does all the work for you. So long as your application is configured for diagnostics, which Craig can show you what that code looks like, once that's turned on, the information starts going out to the table, and you can read that table, build dashboards, and get that visibility as well. It's not just sort of something up there and then you can't talk to it. You can absolutely manage it through App Controller, and you can get the visibility into what's going on. Any questions on? Did I just go off? I don't know. Any questions on any of that? So I'm about to go into that realm now. Yeah. Okay. So Craig he ran a PowerShell script, showed you how you do it in the console. We can do this in one of 2 ways. Let me just bring App Controller back up again. Somehow managed to close that. Connecting to Windows Azure, let's connect to the MMS demo role, and we'll be a service owner. Thank you very much. Okay. So, as with everything, there's a manual way of doing it, and there's an automated way of doing it. We highly recommend you go the automated way, but just for reference sake, if we take a look at the services that are running, and I'll go and scale Craig's act back in again if it has finished, would be the best thing to do. If we take a look at the instance count, we'd take that same application that Craig scaled out with the PowerShell script. We can come into App Controller and see what this looks like. We can take a look at the properties of this and say, well, instead of 10, wind it back down to 1. Okay, so this is the manual way of doing it. We simply go in, change it to the number of instances that we want, click OK, and this is now going to go tear down those. Now, the first question, and we had this conversation up front with these 2 guys over here, was how does that scale out work and how does the scale back in work? In an on-premise application, you either have a hardware load balancer or there is a software load balancer built into Virtual Machine Manager that you can include in your templates. And that allows you to do that scale out, and when you have an application in Server App V and it is in a service template model, you can do that scale in and scale out in the same way. Now, scaling out is really easy. Hydrating an application out is incredibly easy. Scaling it back is hard because you've got to drain the connections, you've got to drain the data and make sure it writes everything back. It does require the application to be aware of scale. And so we're going to start talking in the near future about how to build applications. The application that we used in the keynote, the expenses app, we're going to publish the source code to that. It was written by a partner of ours. We deliberately outsourced that and said, go figure it out and let me know how you get on. We are going to publish the template, publish the source code, publish the whole application, so your developers can pull it apart and see how we did it. There was no smoke and mirrors, there was no magic. It was simply an application that was aware of being scaled, and when a scale in trigger was happening, it drains the connections, drops the data back in, and then scales back in. That information that we have there, now that you see all of that coming through, you can create a monitor in Operations Manager as well, which was when you see this load coming on, what are you going to do about it? And the place that you do that is actually in the monitors of Operations Manager. And in Operations Manager, you've got a number of monitors, and the monitor is configured to say, under what circumstances am I going to scale? Okay, so if I create a monitor that says, hey, when the load hits 65% CPU, I mean, it depends where your bottleneck is, what's going to trigger scale? Is it disk utilization? Is it CPU? Is it RAM? Is it number of transactions per second? Whatever it might be, being able to pick up that parameter, create a monitor, which says, okay, what are we going to do? And as you see, we can either do a unit monitor, which just means a point in time, one-off check for this and do something, or you can do a dependency rollup monitor or an aggregated rollup monitor, which basically means if then, or hey, add all this stuff together, and if the sum total of that adds together, do that. Once you do that, you can then build a management pack out of that, which says when that monitor does this, go run this command. And the command you run would be the PowerShell commandlet or something along those lines. So simply put, then when all that data comes back down and you're monitoring, when you see your application hit those characteristics that you defined, it will scale it out. And so you could have a monitor which says, hey, I've tripped over 65% CPU, or I'm doing more than 10,000 transactions a second, or whatever the number is. I want you to trigger that. The management pack will go, whoa, I've now met my criteria. I'm going to go scale out. And you can just keep scaling out to like, well, we're still over the limit. Oh, no, we're now under the limit. Cool, we're coping. The monitor then can be configured with a lower limit, which is, well, if the limit is only 20, if the load is only, say, 20% CPU, and you've got more than one instance, it's a complete waste of time. Go start scaling back in again. Okay, and you can do that for both on-premise and Windows Azure as well. Okay. Alternatively, you could also have Orchestrator run a runbook, you could have Service Manager trigger something, you could log incidents. There's many ways of doing all of that. It all comes down to what is it you're monitoring, what do you want to do about it, and who needs to know that's going on. If you wanted an approval in that, you could have Ops Manager pick up the fact that your application's going nuts. Log a ticket into Service Manager, or the alert would log a ticket automatically into Service Manager if you had the connectors turned on, and then it would go into an approval process of, hey, your app's going nuts, do you want to go do something about it? If the answer is yes, then go run a runbook, which runs that PowerShell commandlet. So you can completely close loop all of this and bring it together. Question? So if I heard you correctly, what you're saying is there's just basically rules which say when to scale out and when to scale back in. Correct. Yep. Exactly. So yes, the point is that all of this is simply putting a series of characteristics and a series of responses to those characteristics. And if you want to put some approval layers into that, you can. If you just want to go do it, you can also do that. One thing you can also show, and we had this problem in the part 1 and part 2 on Tuesday, is that I maxed out my Azure subscription. I had limits set on my subscription, and my deployment failed in the demo. I was like, wait a minute, what's going on? You can put limits on it as well. And so therefore, you can make sure that you don't get into this kind of, oops, I just scaled out 1,000 instances, and boy, am I going to get a big bill for that. Because Windows Azure as a platform, as a service, you only pay for what you use. So you scale out, and the whole idea of this is to monitor what's going on, scale out when you need it and pay for it, but then scale it back and stop paying as well. So you know, if it's 2 o'clock in the morning and nobody's touching your app, you want to scale it right down to one instance and just really trickle it along. But when it's 2 o'clock in the afternoon and everyone's hitting it hard, then you want to be able to cope with that load. And you can do this, we're talking about Windows Azure today, but this all works for on-premise as well with the service templates. Any questions? All make sense? A few kind of stunned mullet looks. Must be after lunch. Everyone's tired. You've been here a couple of days, starting to struggle. So we deliberately tried to do a lot of demo on this one because it's more interesting to see it. The full set of slides are available as well. We try and do more demo than slides. We know that looking at slideware is kind of boring and stuff, but if we take a look, just to see that it's there, all the information about how this actually works is part of the slides. The service templates on your left-hand side. The service templates and the package and configuration files, as we mentioned, are different. The service templates on-premise that can run on Hyper-V, VMware, ESX, or Xen Server are one construct. They have multiple tiers to them. The package and configuration on Windows Azure is slightly different, as is the application package. Connecting to the subscriptions is just a slide that I put together on how that actually works. The public key is mounted in the Azure subscription, as Craig showed you. The private key is held in the app controller database, and then you just need the API authentication through that. Create your subscriptions and then create your user roles to be able to delegate that out. And we know there's a lot of customers out there who have got multiple subscriptions and want to lock down the live IDs and stop people doing things. This is the way you do it. And the whole point of this is to take control of what you're doing with Windows Azure. We don't want people bypassing IT and going nuts in Windows Azure without talking to them. We need to give you guys the tools to be able to manage that. And it's a value-add service because not only can you give them the self-service in a controlled fashion through App Controller, but you can also do all the monitoring, and that's something they're not going to get if they're bypassing you. Okay? The only way to get the information out that we talked about is through Operations Manager. That is the way that the value you can add is, hey, we not only can see what you're doing and control that, but we can show you how well it's working as well and make sure you're not wasting resource. Question?
So if they deploy directly, but not to give us a come back.
Yeah, so Craig actually did the deployment of that app in the console, and I went into App Controller and can see the same thing. So the back end is the same. It's just a matter of, do you want to see it in the web console for Azure, or do you want to see it in App Controller? But it's still connecting to Azure's subscription and seeing all that information. So you could actually have a monitor on that to see whether an additional app turns up and do an alert to say, hey, someone deployed something new. Like, was that approved? And also when it scales, you can be alerted to the fact that it does that as well. And then from a monitoring perspective, this is how that actually works. So you configure the diagnostics, you turn it on in the Windows Azure application. That writes out to table storage. Operations Manager authenticates just like App Controller through the Windows Azure Service API, and then we read that table storage and groom it and make sure that we do it, and we move that information down into the Operations Manager database, which also turns up in the Operations Manager data warehouse. So when you run reports and trending and all that kind of stuff in Operations Manager, you're getting all that information. And then we talked about building out those diagram views. If anyone wants to see that, we do actually have some time. We can build a diagram view if you want to see how we actually do that. So that's all the content that we have. If people want to see additional things, then we've got time. Otherwise, you can have a bit of extra time back to grab some coffee, grab some food, chill out, network. Any questions? Anything you didn't see that you wanted to see? I know it's like Wednesday afternoon after lunch and people start to struggle, believe me. We know.
Can I ask just a quick question? How many folks in the room are already using Windows Azure? Are there folks inside your organizations who are using Windows Azure?
That you know about?
Wow, okay.
Anybody suspect they're using Windows Azure that you don't know about?
So we didn't go very deep into Windows Azure in the session. The intent of the session was not to go very deep in Windows Azure. I had a Windows Azure overview session earlier in the week. But if you would like to get a little bit more of a deep dive on what Windows Azure is, how it works, and ask some more questions, please come by the booth. We also have a 90-day free trial that's available for Windows Azure. You can sign up for windowsazure.com. There's a big button in the upper right-hand corner, free trial. So if you want to go load some sample apps up there, we've also got some sample app packages we can give you in the booth, so you can throw them up in Azure and and play around with them to actually see how all this stuff works. So please stop by, and we'd be happy to help you get set up.
We're going to do the same for a lot of the demo apps. Greg's team building Windows Azure demo apps, and the Keynote application that you saw, the Contoso Expenses, we're going to publish that on download.microsoft.com with the full source code as well. So the whole point is to give all of you guys the content to download the evals, publish out and learn how the apps are built, pull them apart, see the source code, and deploy them out and play with them. So we don't want you to have to go and reinvent some wheels just to do some proof of concepts. You should be able to just grab some stuff and deploy it. All right, well, please do your evaluations. We want to know, what you thought. If there's things you didn't want to see and you're not a bit scared to say it out loud, that's fine. Put it in the eval. We do read them all. We do measure them all. And there's a load of information on the MMS-2012.com website. All the sessions are recorded. All the slides are available for download, that kind of thing. So thank you very much. We appreciate you taking some time, and go and grab some coffee and wake up for the last sessions. Thanks, guys.